So one solution which is very closer to the optimal solution can be the Vogel's approximation method solution. Okay. So whenever in the exam, if they don't specifically ask about the which method to follow for the basic feasible solution, then you may follow only Vogel's approximation method because it is quite nearer to optimal solution. It sometimes can be the optimal solution itself. Okay. So today's class, that yesterday's matrix, whichever I have taken was 4x5 matrix. It will be little difficult for me to take up with that numerical. So I'm taking one 3x3 matrix wherein 3 plants are there. Am I audible there? Can you confirm?
Yes, ma'am.
Yes. So I'll be taking 3x3 matrix and a solution which is already done by northwest corner method I'll be taking, and then I am solving it as per the two optimization methods are there. We will see that in detail. Okay. So I will draw here. Yeah. 1 minute. I'm not able to. Johnny. Yeah. Okay. 1 minute. Please bear with me. I'm not able to use this pencil properly. Yeah. My helper is gone down. My son, he is not here now. Okay. Yeah. So it's basically 3x3 matrix. Okay. So W.
Madam, maybe you can take an Excel and put it there. What document with table?
This pencil is better, sir. But okay, I'll try doing that, sir. 1 minute. Yeah. That's a good idea. No, sir. Actually, code will be better. 1 minute, sir. Johnny. Fast one, please. Signal coded. Minimize பண்ணுங்க. Erase பண்ணு. Delete பண்ணிடலாம். Delete பண்ணி 3x3 matrix, please. 3x3 matrix. Yeah. So meanwhile, I'll give the explanation. Okay. So allotment is done by either of the methods. Okay. Yesterday, what we have done was we have found out feasible solution, which is practical solution. Okay. So we have seen 3 methods and 2 more methods, row minima and column minima. You can see it from your study material. Okay. So northwest corner method, least cost method, and Vogel's approximation method we have seen. Okay. So by that, we have found out a solution which was feasible, practical solution. Okay. But it need not be the least cost solution. So today's class, we will try to improvise the solution which we have got by the feasible solution, initial basic feasible solution. For finding out the optimal solution, there are two methods. Okay. Those two methods are stepping stone method and Modi method. Okay. Modi stands for modified distribution method. Okay. So I'll be doing Modi method first and then tell you in the last what is stepping stone method. Okay. So meanwhile, some of the part of the even stepping stone method you will be able to understand. Right? Okay. So now what we have done was we have found out allocation. Okay. Now whatever cost which are given in the matrix, that we can write down here like this. Okay. 4 in a here. Okay. And then 8. Then in the third column 8. These are costs. 16, 24, 16, 8, 16, 24. The first row is W, plant W. And plant W is producing 56 units. 56 units. Then next plant is plant X. Capital X. It is producing 82. 82. Then third one is plant Y. It is producing 77. So we have to supply to different projects. Project B. Project C is demanding 41. Okay. So can you quickly tell me, is it a balanced problem or unbalanced problem? Is it a balanced problem or unbalanced problem? See, I have written the cost in a different fashion. That's all. I have written it in the corner like this. That's all. Okay. And demand and supply are here. How much is the demand of project A? How much is the demand of project A?
72.
72. Okay, how much is the see, W, X and Y are plants. Okay, plants. And these are the warehouses, suppose. Warehouses. Okay. How much is plant W supply?
56.
56. And plant X?
82.
82. Okay. So is it a balanced problem? Is the total demand equal to total supply?
Yes, ma'am.
Yes. So can we move ahead to step 2?
Yes, ma'am.
Unless otherwise mentioned, 4, 8, 8, 16, 24, we treat it as cost. So is it a minimization problem or maximization problem?
Minimization.
Minimization problem. So we can go ahead with the third step. We will find out the feasible solution by using northwest corner method. Okay. So this is the northwest corner method. How much I can allocate here? How much I can allocate here? In WA cell, how much I can allocate?
56.
56. Yeah. 56 on a circle. Yeah, you can circle 56. You can circle 56. Okay. Then, is the demand got over or supply got over?
Supply got over.
Supply got over. So please strike off that first line. Strike off the first row. How much of the demand is left over still? Out of 72, 56 is met. So how much is left over? Strike.
16.
How much?
16.
16. Don't 16 here. Next, to which cell should I come?
XA.
XA. How much should I write there? Demand is 16, supply is 82.
16 demand.
16. Yeah, 16. Write down 16. Circle it. Okay. Then is the demand got over or supply got over?
Demand got over.
Demand got over. Strike off the first column. Strike off the first column. Then how much of the supply is left over? 82, strike off 1. How much of
66.
supply? 6. How much?
66.
66. Which cell should I come later?
XB.
XB. How much can I allocate there? 66 or 1 or 2?
66.
66. Allocate 66. Yeah. Is demand got over or supply got over?
Supply got over.
Supply got over. So strike off the supply. How much of the demand is to be met?
36.
36. Yeah. To which cell should I come later?
YB. YB cell.
So 77.
36.
36. Allocate 36 there. Circle it, please. Circle the allocations. So is demand got over, supply got over?
And
Demand. How much of supply is left over now?
41.
77 strike off 41. Yeah, in the last cell, how much should I allocate?
41.
41. Yeah, write down 41. Yeah. Is this solution clear? Feasible solution? Circle.
Yes.
Yeah. Now, what we'll do is you can write down in your books without striking off how we have allocated. Okay. Write down draw the matrix again. Okay. Draw the matrix again here. Don't write 56, 66. Draw matrix in your book. 3 by 3. You draw. Yeah. After you get the feasible solution, please you draw it again with only cost and allocations. Okay. The allocated cell, can you name the allocated cell? What are they? WA? WA?
XA.
Yeah, XA.
XB. XB. YB.
Yeah.
YC.
Okay. That allocated cells are known as stone cells. What are they known as?
Stone cells.
Stone cells. And what are the unallocated cells? WB?
WB. WC.
WC,
X.
Y,
YA. YC.
Yeah.
Sorry. A.
Unallocated cells are known as water cells. What are they known as?
Water cells.
Water cells. Okay. So maybe you must have seen in the old movies, there will be a pond containing water and will be some stones. In the song sequence, you must have seen. So you can imagine this is to be a water pond wherein some stones are there. Okay. Will you be able to walk in water if you don't have sufficient stones? Will you be able to walk in the water if you don't have sufficient stones in between?
No, ma'am.
No. So you should have sufficient stones to walk. Otherwise, it will lead to degeneracy. Okay, wherein we can't find out the solution. So what is that requisite number of stones? Requisite number of stones is given by M plus N minus 1. Okay, where M is number of rows, N is number of columns, and 1 minus 1. So how many stones do we need to find out, to go ahead with the next step? How many rows are there? How many rows are there? How many rows are there?
3 rows.
3 rows. How many columns are there?
3 columns.
3
3
columns.
columns. So 3 plus 3 minus 1. So how many stones should we have?
5.
5. So do we have requisite number of stones? See, 56 WA is 1 stone, XA is 1 stone, XB is there, YB is there, YC is there. Are the number of stones enough?
Yes.
Yes or no?
Yes.
Yes.
Enough.
We can go ahead. Okay, we can go ahead with the next step. John, please. So now what we have to do is we have to see if in the cell WB, WC, XC, is there any improvement possible? We find out improvement index for the water cells. Okay, what do we find out? Improvement. What do we find out? Is the full screen visible to everybody?
Yes, ma'am.
Yes. So
Yes.
yeah. So what we do is, see this, we can go ahead with the optimality. We have to find out improvement index. Improvement index. To find out improvement index, there are 2 methods. Okay. Stepping stone method or Modi method. Okay. Modi method. By both the methods, whatever improvement index we get is same. Okay. Whatever improvement index we get is same. Okay. So we will start with the Modi method, then we will come to stepping stone. Okay. So how do we find out improvement index and what does improvement index means? Okay. If improvement index is positive, okay, if improvement index is positive means it is not good. Okay, the cost, if you allot something there, your cost is going to increase. Your cost will increase. If the improvement index is negative, your cost will increase. Okay, if it is negative, improvement index is negative, means your cost will decrease. If the improvement index is 0, it means that cost will neither increase nor decrease. Okay, so where there is a chance of reducing the cost? Is it when improvement index is negative or positive? Where is the scope of improving? Can someone quickly find out the cost for this solution and tell me? 56 into 4, 16 into 16, 66 into 24, 16 into 36 into 16, 41 into 24. Can someone find out the cost and tell me? Can someone find out cost and tell me, please?
264. 4 into 66. 264.
Yeah.
256. 16 into 16.
56 into 4 is 264. Then 16 into 16 is 256. Yeah, please find out the total cost and tell me.
1584. 24 into 6.
Yes, sir. 56 into 4 is how much?
56 into 4 equals to 224.
224.
Yeah. Then 16 into 16.
256.
256. Then 66 into 24.
1584.
1584. Then 36 into 16.
576.
576. Then 41 into 24.
984.
How much?
984. 984.
984.
Yeah, how much is total cost?
$3,624.
Yeah. Now our objective is, can I reduce this further? Okay. So that will become an optimal solution. Okay. That will become an optimal solution. So what we'll do is, we will try to find out the improvement index for the water cells. Okay, how do we find out the improvement index for water cells? So we have to find out the index numbers. So I will call the index number for row 1 as R1, R2, R3, then K1, K2, and K3. For columns, we call it as K, and rows, we call it as R1. Okay, R1, R2, R3. So now erase this, please. Okay, now what we'll do is, anyone, R1, R2, R3, or K1, K2, K3, I will assume it as 0. Okay, so my favorite, whichever you want, you can assume it as 0. Okay, so which one you want me to assume it as 0? Any one, I can assume it as 0. R1, should I assume it as 0?
No, either K1 or K2, madam.
Okay, K1 I'll assume it as 0. Okay, K1 0. K1 0. Okay, so now the thing is, for the stone, WA is the stone, isn't it? Yes. WA, is it a stone or water?
Stone.
Stone. For a stone, the row index number and column index number, if I add, I should get the cost. Means R1 plus K1 is equal to 4. Is equal to 4. So K1 is 0. How much is R1?
4.
4. So write down 4 here. Okay. This I can do with the help of stones only. Okay, 1 I have to assume it as 0. Then slowly I have to find out other index numbers depending on the stones. Okay. Now, for this stone, you can see for the R2 and K1 stone. Okay. So R2 plus K1 is how much? How much is cost there?
16.
16. So K1 is 0. So how much will be R2?
16.
16. So write down 16 there. Are you getting the point? Any one we have to assume at 0 and then slowly find out the index numbers by using the stones. Now, can I take this stone, 66 stone?
Yes.
Yes. So tell me the equation for that. R2
R2 K2 is equal to 24.
Very good. 24. Yeah. So R2 we have already found out 16. How much is K2?
8.
8. Right. So write down 8 here. Write down 8. Yeah. Can I find out R3 by using 36 stone?
Yes.
Yeah. Tell me the equation for 36 stone.
R3 plus K2 equal to 16.
Very good. K2 equal to 16. So K2 we have already found out. So can't we find out R3?
Yes, 8.
How much is R3? 8. Yeah. Now, can't I use the 41 stone? Yeah, tell me the equation for 41 stone.
R3 plus K3.
R3 plus K3 equal to 24.
Yes,
Okay. Yeah. So R3 is 8. K3 we don't know. So how much is K3?
16.
16. Is the index numbers clear?
Yes, ma'am.
Yeah. Now what will happen is if the stones are not enough, we won't be able to find out index numbers. Okay. How did we find out the index numbers? By using the stones, isn't it?
Yes, ma'am.
Suppose if stones are not sufficient, we will fall in water. Okay. We won't be able to find out index numbers. Okay. So that condition you have to check it before. Can we proceed further? So by using the stones, we have found out the index numbers. Can I erase this left part?
Yes, ma'am.
Yeah. So is the index numbers clear to everybody?
Yes.
Anyone, you can take it as 0 and you can proceed. Okay, there is no problem. The improvement index, you will get it same. Now we have to find out improvement index for WB, WC, XC. Yeah, improvement index. Improvement index. Improvement index. Okay, for WB, capital B, equal to, yeah, how we find out the improvement index is, the formula is C, cost minus the row index number plus column index number. Okay, so for WB, how much is the cost? How much is the cost? WB. WB, how much is the cost?
8.
8. Yeah, how much is the row index number for the first row?
4.
4. How much is the column index number?
8.
8. So how much is improvement index? 8 minus 12. How much is index?
4.
Minus 4 or plus 4?
Minus 4.
Minus 4. Please be very careful with the sign. Okay. Next, WC. WC equal to, how much is the cost?
8.
8. 8 minus, brackets open. How much is the row and plus column?
4 plus 16.
Very good. 4 plus 16. How much is the answer?
Minus 12. Minus 12.
Very good. Minus 12. Then, which is the water cell? Next.
XC.
XC. Yes, very good. XC. XC equal to, small capital letters use one. How much is the cost?
16.
16 minus row index number.
16 plus 16.
16 plus
16.
16. How much is the index number?
Minus 16.
Minus 16. Very good. Then next is
YA.
YA.
YA. For YA, tell me the improvement index.
8 minus 8 plus 8.
Yeah, 8
Minus
plus
8
bracket open,
plus
8 plus 0.
0.
8 plus 0. Okay. So how much is improvement index?
0.
0. Right. Now, what does this improvement index mean is, now this improvement index will be same by both the methods, Modi method and stepping stone method. Are you getting the point? These improvement indexes, whichever we have found out, will be same by both the methods. Okay. So what do this improvement index means is,
Now which method you are following, madam? Modi method or stepping stone method?
Modi, sir. Modi method.
Okay.
Okay. So now what does this negative index number mean? Improvement index means is, see, if the water cells are the empty cells, isn't it? Water cells, are they empty cells or occupied cells?
Empty cells.
Empty cells. If I'm going to allot 1 unit in that particular cell, I will be saving 16 rupees. Minus means that I will be saving money. So, do you want to save money or spend more money?
Save money.
Save money. So, which saving is better? Minus 4, minus 12 or minus 16 is better?
Minus 16.
Very good. So, we will improve this cell now. XC we will improve. Did you understand this? See, this particular cell we will improve now. Okay. Because if I'm going to allot something here, I'm going to save money. Is that clear?
Okay, ma'am.
How much am I going to save? 16 rupees per unit. Okay. So now for this cell, I have to find out a closed loop. Okay. Can you step on water? Unless maybe you are God, you can't step on water, isn't it? Can you step on water or can you step on stone?
Step on stone.
Yeah, I have to step only on a stone. Okay. So now I have to, for this XC cell, I have to find out a loop such that I have to start from here journey and come back to my home. Okay. So I am stepping on this stone. Can't I step on this stone? 66?
Yes.
Yes. Then I will step on 36. Can't I? Do
Yes.
that? Yeah. Then I will step on 41. Yes.
Ma'am.
Yes.
And I will come back home. Isn't it?
Yes.
Yes. So my loop is very simple. I am starting my journey from XC. Then I am stepping on XB. Then I am stepping on YB. Then I am stepping on YC. Then I am coming back home. Isn't it?
Yes, ma'am.
Yes. Is the loop clear?
Yes, ma'am.
Yes. Yeah. So now I will take only this loop. Okay. Erase this one, please. Either. Erase. Okay. How do we improve? I will show you here. I will draw that only that 4 cells and I will show the improvement. How do we improve it? Okay. So you can draw only that particular 2 by 2 matrix. Please. Okay. You can draw that 2 by 2 matrix. 2 by 2. Here 24, 16, 16, 24. You get 24 now, cost 24. This one. It's the same, Nana. It's 2 by 2 matrix copy panna. Geta. Erase panna. 24 is the. Huh. 24, 16, 16, 24. Yeah. Okay. Yeah. Did you all draw? Yeah. Okay. So from wherever I have started the loop, there I have to put plus. Okay, plus. And next I have put my step here. So put minus here. Put plus, minus. Alternate plus and minuses. Okay. Alternate plus and minus. Is that clear? Is it clear?
Yes, ma'am.
Yes. So now wherever I have put plus means I am going to add something there. Okay. Wherever I have put minus, there from there I am going to reduce. See, Einstein's law says mass can neither be created nor destroyed. Okay. So I can just remove from one cell, add in another cell. That's all. That is what I can do. I can reallocate. Okay. Out of 41 and 66, which is the smallest number? Out of 41 and 66, which is the smallest number?
41.
41. So what I'll do is, I will remove 41 from here. Okay. And put it here. Are you getting the point?
Yeah.
I'm removing 41 from here, putting it here. Yes? Did you understand?
Yes, ma'am.
Yes. And I'm removing 41 from here also. If I remove 41 from 66, how much is remaining?
25.
How much?
25.
25. And I am putting it here. 41 plus 41. So how much will have become here? How much will it? 70?
7.
77. Very good. Okay. So erase it. 66 erase one, no? 66 either erase one. Yeah. So I'm changing it in the original matrix. Out of 66, now only 25 is left. 25. 25. Are you understanding the point? Circle पर. हाँ, 36 77 pan. 77. हाँ, circle pan. Circle. इधर 41 है. இது எடுத்துடு full எடுத்துடு 41 வானா அங்க MBA செல் இங்க 41 41 yeah now yeah I'll come again. See what we have done was we have removed from one cell 41. From this cell I have removed 41, put it here. Are you getting the point?
Yes, ma'am.
Yes, and I have removed 41 from XB cell and put it in YB cell. Is that clear?
Yes, ma'am.
Yes. Now what you do is you check the cost now. You check the cost. 56 into 4 plus 16 into 16. $56 into 4, 16 into 16, plus 25 into 24, 41 into 16. Yeah, can you tell me quickly, please? 56 into 4, how much is that? How much is that? 1 minute.
224.
224. Then 16 into 16.
256.
256.
25 into 24.
600.
600. Then 41 into 16.
656.
656.
56.
656. Then 77 into 16.
1232.
1232. Then that's all. Yeah. How much is the total cost?
2936.
29?
Yes, 2968, ma'am.
2968. Is this cost better or previous one was better? How much? Which one is better? On the path.
This one only.
This one only. How much is the saving? Can you someone tell me? Previous one was 3624.
3624 minus 2968.
2968. How much is the saving?
656.
656. How much was the improvement index for XC cell? Minus? How much was the improvement index? You have calculated, right? -4, -12, -16, isn't it?
Minus 16.
-16. So how many units did we allot in XC cell?
41 units.
41 units. Previously it was empty. Now we have allotted 41, isn't it? Just multiply 41 into 16. Tell me how much is it?
656.
Yeah. Did you understand the point? See, improvement index will tell you if I am going to allot 1 unit there, I am going to save 16 rupees. But how many units did I allot?
41 units.
41 units. So how much is my saving?
656 rupees.
656 rupees. Did I save 656 rupees? Did I save 656 rupees?
No.
Yes. Previous cost was 3,624. Now the cost of the new allocation is 2,968. Didn't I save 656 rupees?
Yes, ma'am.
Yes, isn't this a better solution?
Yes, it is
Yes.
better.
But is this the best solution? Is it the best solution?
Yes, ma'am.
I can't say. Okay, now this is our new matrix. Either R1, R2, R3 K1, K2 So what we'll do is, for this new matrix, we will try to find out R1, R2, R3, K1, K2, K3 again. Okay, so which one do you want me to think of as 0? Last time your suggestion was I should take K1 as 0. Anyone, you can take it as 0.
KB.
Yeah?
KB.
1 minute. R1, R2, R3, K1, K2, K3. Yeah, now tell me, which one you want me to assume as 0?
K2.
K2. Okay, K2 is 0. K2 is 0. Okay, now tell me, can't I make use of 25 stone?
Yes.
How much is R1, R2? How much is R2? R2 plus K2 should be 24. How much is K2? R2 is how much?
24.
24. Okay. R2 is 24. So please write down R2 is 24. Yeah. How much is R2? 24. Can't I make use of the 16 stone?
Yes.
Yeah. R2 plus K1 is equal to 16. So how much is K1? R2 plus K1 is equal to 16. How much is K1?
-8.
Very good. Write down -8. Then, can I make use of this 56 stone? 56.
Yes.
Tell me the equation for 56 stone.
R1
plus K1.
Plus K1 is equal to
6.
4.
4. Very good. So K1 is -8. How much is R1?
12.
12. Then, can I make use of this 77 stone?
R3 plus
R3 plus K2
is equals to 16.
equal to 16. Yeah. R3 is how much?
16.
16. Then, can I make use of 41 stone?
Yes, ma'am.
Yeah, tell me.
R2 plus K3 is equals to 16.
2 plus K3 is equal to 16. So how much is K3?
Minus
24 plus K3 equal to 16. K3 is?
-8.
-8. Very good. Okay. Now the next step is I have to find out improvement index for all the water cells. It is this. Either left. This matrix it is. Okay. What are the water cells now? What are the water cells?
R1, K1.
No. WB, WC, then YA,
C.
Okay, we call it as W, X, Y, no? These plants. These are ABC. Okay. So please tell me improvement index for WB. cost minus
Row.
row index number 12 plus 0, isn't it? How much is the improvement index?
-4.
-4. WC, tell me for WC. 8 minus 12 minus 8, isn't it?
12 -8.
8 minus 4. 8 minus 4. How much did you get?
4 plus 4.
Yeah, here no improvement is possible. Okay. YA, cost minus 16 minus 8.
Zero.
0. Then YC, 24 minus 16 minus 8. Yeah.
16.
16. Yeah. Where is improvement possible?
WB.
WB. Okay. Can you see the difference? Last time we have got all negative numbers, but this time only one is negative, isn't it? Yes.
Yes, ma'am.
Yeah. So next time we won't get even that one also. Okay. So that will be the optimal solution. Okay. So shall we improvise WB?
Yes, ma'am.
Yeah. So for WB cell, I should find out a loop. WB is this cell, isn't it?
Yes, ma'am.
Yeah, for this, I have to step only on a stone and form a loop. I should start my journey here. Where should I step now?
56.
A.
Very good. Then
R2. R2 K1.
16. Then
25.
25. Then back home.
Hi.
Okay. Okay. Are you understanding the loop? See, as soon as I'm stepping on a stone, I should change my direction. If I'm moving in a horizontal direction, I should make it vertical. Okay. Is that clear?
Yes.
The rule, and I can't step on a, suppose if there is a, in between water is also there, I can jump and step on the next stone. Okay. That is possible. Okay. Yes. Now tell me, only that particular matrix, 2 by 2 matrix. 2 by 2. Yeah, tell me the improvement now. In the WB cell, what should I put? Minus, plus. Okay, from wherever I'm starting, I should put plus, followed by minus, plus, minus. That's all. Okay. Sorry, done. See, in this cell, I have 56, 16, 25. Okay. Here I have to put plus, minus, plus, minus. Is that clear?
Yes, ma'am.
Yeah, from minus indicates that I'm going to remove something from there. Okay. Plus indicates I'm going to add something there. Is that clear?
Yes.
Yes. So out of 25 and 56, how much I can I remove 56?
No, ma'am. 25.
No.
I can remove 25. So this 25 I will remove. Okay, this 25 I will remove. Put it here. Okay. Yes.
Yes.
Yeah. From this 56 also I will remove 25. So how much is left over here?
31.
How much?
31.
31. And to here 16, I will add back this 25.
41.
41. Is it making sense?
Yes, ma'am.
Yes.
Yes. Now, please. I will make the changes in the new that old matrix only. 56 erase pan. 56 erase pan. 56 either first cell. 56 erase panni 31 is there. In the first cell, I have 31 units only now. Okay. In this cell, 25 circle bar. In this cell, 41. Erase pan 41. This completely erase pan. 25 erase pan. Podu. Idle 41 is there. 41. Is the new matrix clear now? Is the new matrix clear?
Yes, ma'am.
Yeah. So what we have done is we have tried to find out the index numbers, then followed by improvement indices. Improvement indices, whichever is negative, we have to take only that, form a loop in that particular cell, and then improve. That's all. Okay. Now, can you find out the cost for the new matrix? Johnny, the erase panna na? Idalla erase panna. Idu table. Full. How much is the cost now? 31 into 4, 25 into 8, 41 into 16. Then 41 into 16 once again. Then 77 into 16. Yeah, please, can you tell me?
124,
124,
24, 200,
56,
656, 656,
56, 656 again,
1232,
1232. Can you tell me the total?
two eight six
68. Is it better than the previous one? See, the first solution was 3,624. From there, we have brought it down to how much?
2968.
2968. From there, we have brought it to 2868, isn't it? Isn't this the better solution?
Yes, ma'am.
Yes, ma'am.
See, how much was the improvement index for this cell?
100,
WE cell. No, improvement index. Minus 4.
4 minus
Isn't it? Yeah. How many units did we allot?
31.
25 in
Oh, sorry. 5.
WB cell. How many units?
25.
25. So how much is our saving? Isn't it 100?
Right.
Yes.
Yes. See here, difference between 2968 and 2868. Isn't it 100?
Yes, ma'am.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yes. So did you understand this method? How to improvise? Now you can ask me a question. Till when do we have to do it, ma'am? Okay.
Yes, ma'am.
We have to do it till all the improvement indexes are 0 or positive. Till there is no further improvement possible. Okay.
Okay, ma'am.
Yes. I think this will be the optimal solution. Okay. You can check out. How much time do I have still?
3 minutes.
3 minutes. I don't think I can move on further. But stepping stone is much lengthier method. Actually, you have to find out.
Ma'am, excuse me. This last step, can you explain again, ma'am? -4 into 25.
How much was the improvement index? We have found out improvement indexes for all the water cells, no? How much was the improvement index for WB?
25.
Minus
No,
4.
improvement index.
Minus 4.
-4, isn't it?
Oh, okay. Yes, ma'am.
1 unit you are going to allot there. I'm going to say 4 rupees. How many units did we allot?
25.
25. 25 into 4 is 100. So isn't there a saving of 100 rupees?
Yes.
Yes. Did you understand the point?
Yes, ma'am. Yes.
Okay. So these are all very scientifically laid methods. So they can't go wrong. Usually we can't challenge these methods. Okay. They have done by the best of statisticians during Second World War. And they have meticulously formulated these methods, found out these methods to solve the problems. Okay. Okay. So is it clear?
Yes, ma'am.
Any doubts?
Ma'am, we should have to draw all the boxes
Yes,
from.
yes, we have to draw. You have to quickly do the problem. Okay. That shouldn't take much time because along with the explanation, it took so long. Okay. Without explanation, you will be doing, and in the exam hall, there will be pin drop silence. So you will be able to do it soon only. Okay. Don't have to worry. You will be able to do fast. Okay.
Have
You
to
can
show
try-
calculation also, ma'am. For the
Yes.
calculation also we have to draw for only boxes.
Boxes you have to draw after the change. How does the box look like? You have to draw that box, find out the cost. Then again, find out index numbers, improvement index, again change it, again show the changed matrix. Okay. Yeah, I can't really help because you need continuity. Next class, I think you will be able to understand. One who was absent yesterday, please. Next class, I'll be doing assignment problem. So that has nothing to do with transportation. That's an independent thing. Okay. So I can wind up assignment problem in the next class. Okay, tomorrow's class. Okay, is the transportation problem clear?
Yes, ma'am.
Okay. Initial basic feasible solution, if you find out by Vogel's approximation method, your iterations will become less. You will be very close to the final solution. Okay. So many iterations won't happen. Just because
Ma'am, this is only Modi method only.
Yeah. Stepping stone method is quite simple, ma'am. Means if you have understood that forming loops, no? You need to form the loops for all the water cells. I will show you, yes, tomorrow's class.
Okay.
Okay. Yeah.
Thank you, ma'am.
Okay. Thank you so much. Good night. It's not logging off. Maybe we'll, yeah. No, don't leave. Don't leave. I'll cancel out. If there are any doubts are there, you can ask me.
Ma'am,
Yes.
actually yesterday because of weather issues, I'm not able to attend the class. So can I listen the class on YouTube or anywhere else?
I don't know, ma'am. I really don't know. It is saying that it is been live streamed. You can see it on the YouTube. Then.
I searched but not anything. Okay.
Then you need to talk to your coordinator because I don't have the links.
Okay, ma'am.
Talk to your coordinator, no, please.
Okay, ma'am. Yesterday, what class you have said, ma'am?
We were solving initial basic physical solutions.